24. Is there anyone who still has their test? If you have it and you have finished looking at it, please bring it on up. If you need to look at it for a little while longer, that's okay, but I would like it back before the end of day today. And we are on page 24.
Let's talk about ionic bonding in much more depth. In the previous video, we talked about the basic fundamentals of how ionic bonds get made in sodium chloride. Now, I want to look at why and how these steps happen.
Now, I think you guys already know why and how these things happen. Why does the sodium give an electron to chlorine? We're on page 20, what did I say, 27? 24, if you're not there yet. Why does sodium give an electron to chlorine? Tell your partner.
I visited some very nice mountains today.
Okay, now that you've had a little discussion about it, we are going to go through this. Hudson, are you on your phone? Could you go put it in the cell hotel, please? Thank you.
During the formation of ionic bonds. In order to really understand what's going on in ionic bonding, we have to take a look at the individual electrons that live in sodium and live in chlorine. Now, as you probably know, there are specific places in an atom where electrons can live.
It does bother me that he hasn't paired up his electrons properly, but you know, nobody's perfect, even Tyler.
Okay, I have a diagram of this here. If this is new, you should check out my video called Valence Electrons and the Periodic Table. Anyway, each one of these little circles represents a spot that an electron can live in an atom. And you'll see that these little electron spots are arranged in rings around the nucleus of the atom. Each one of these rings is called a shell or an energy level. Okay? So we can use this diagram to figure out where the electrons live in sodium and where they live in chlorine. Okay? First thing we got to do is we got to find out how many electrons there are in these two atoms. Okay?
Do you remember how to do that? How many electrons are in a sodium atom? The atomic number, yes. And the atomic number is 11. How many are in chlorine? Actually, the thing's right up there. How many are in chlorine? 17. There we go.
Now, sodium here, you look it up on the periodic table, it's got this 11 here. That means it has an atomic number of 11. There are 11 protons in sodium. Now remember, when ionic bonding starts, these atoms are not yet ions. They don't have a charge. They're neutral. So that means that they have the same number of protons and electrons. So there are 11 protons in a sodium atom. That means there are also 11 electrons in a sodium atom. Okay, the same thing is true with chlorine. It has an atomic number of 17 protons. It's starting out without a charge, so it has 17 protons and 17 electrons. Now, we can take one of these diagrams and fill it in from the center on out with a number of electrons. So, for sodium, that's going to look like this. 11 electrons arranged around the atom from the center out. And for chlorine, it's going to look like this. 17 electrons arranged around this from the center out. Now,
So why do these things form ions? Why do they bother? Yes. So they can have a full valence shell, absolutely.
you may not be able to tell from these diagrams, but these are two very unhappy atoms.
Never use the word unhappy when it comes to atoms. Always use stable and unstable, or high potential energy and low potential energy. Happy and unhappy, it's a really nice way to think about it, but atoms don't actually have emotions, shockingly.
The reason why has to do with their valence shells. You remember what valence shells are? They are the furthest out energy level that still has electrons in it. Okay, so for example, this is the valence shell of sodium. It's got one electron here. And this is the valence shell, the furthest out shell for chlorine. Okay? The reason why these two atoms are so pissed off is because every atom wants to have a full valence shell. It's like,
Okay, so we can fill that in on our handout there. Every atom wants to have a full valence shell.
every atom's goal in life. Sodium is really unhappy because it only has one electron in its valence shell, and it has these 7 empty spots. Okay? Chlorine, on the other hand, is also upset because it's got a mostly full valence shell, but it's got...
That was supposed to be a mostly, not emotionally full in the subtitles. I don't know if any of you caught that, but anyway, that's okay.
one empty spot. It's so close. It's so close, but it's still super unhappy because the valence shell isn't full. So sodium and chlorine are both unhappy. They both want to fix their situation. And in trying to fix it, that is how they're going to end up with an ionic bond. Okay, so how are sodium and chlorine going to get happier? How are they going to fix their situation? How are they going to try to fill their valence shells? Well, take a look at this. They can help each other out, okay? Chlorine has one spot left before it's able to fill its valence shell. And so what happens is sodium can give chlorine one of its electrons, okay? So this electron moves from sodium to chlorine to fill this spot.
Okay, so you guys can fill in the blanks for sodium, which has 11 protons and 11 electrons. You can fill in the blanks for chlorine, which has 17 protons and 17 electrons. And you can fill in the box in the middle. Atoms want full valence shells.
Here's what we end up with. Okay, let me just show you what's going on here. Okay, so we got sodium, we got chlorine, and this electron up here moves between them. Okay, so it leaves sodium and it goes into chlorine. Okay, and now chlorine has filled this empty spot with one of sodium's electrons. Okay, so now chlorine is super happy. It has a full valence shell. It's achieved its goal in life. But take a look at sodium over here. Though you may not know it, sodium has also achieved its goal in life. Because when it gave this one electron, when it gave the electron to chlorine, it totally emptied out this valence shell. Now you might think, okay, that made it even worse because now it has 8 empty spots it has to fill. But here's the thing. If you can get rid of all of the electrons in your valence shell, it's like that valence shell just disappears. Sodium doesn't even have to worry about it anymore. Okay, so it gave away this last electron in its valence shell, and now it's like the valence shell just disappears. And this is now sodium's new valence shell. And check it out. It's totally full. So by giving away that one electron, it could get rid of its whole outer shell, and this is its new valence shell. It's full, and sodium's happy. So this is what we end up with. Let me just show you what the intermediate steps look like here. And this is what it looks like when sodium gave it away, and we can sort of think about it still having this outer shell. And here is chlorine with the new electron from sodium. So we've got step 1, step 2, step 3. Okay, so now chlorine has a full valence shell. Now sodium got rid of its old valence shell, and its new valence shell is totally full. They're happy. But let's talk about what's going on with the electrons here, okay? Because there are electrons moving. Now, over here with chlorine, it used to have 17 electrons, and then it got a new electron from sodium. So it doesn't have 17 electrons anymore. Now,
How many electrons does it have now? 18.
it has an extra one, so it has 18 electrons. But it has the same number of protons because we weren't moving protons in this example. Okay? So it's still got 17 protons, and it's got 18 electrons.
So what is its net charge? Is it positive or is it negative? Negative, because it has more electrons, which are negative.
But now there's an imbalance between the number of protons and electrons. It doesn't have the same number of protons and electrons anymore. It has more electrons, which means that it has a negative charge. It has a negative charge of 1 minus because it has one more electron that it got from sodium. And now we can call it an ion. Now, sodium also became an ion, right? It used to have 11 protons and 11 electrons, the same amount, so it used to be neutral.
Sorry. I don't know what I'm doing. I meant to get rid of the closed captions. So you could fill in the blanks. On the right-hand side at the bottom of the page, it says 17 protons, 18 electrons, and a negative 1 net charge. What do you think is going to go in the blanks on the left-hand side of the page? Tell your partner. Okay, let's see.
But not anymore, because it gave away one of those electrons, so now it only has 10. But it's still got the same number of protons. It's got 11 protons with positive charge, and it's got more protons and electrons. One more proton. And that means it's going to have a positive charge, okay? It's going to have a 1 plus net charge, and it also is going to be an ion, an atom with a charge. So this guy over here has a 1 minus charge. This guy over here has a 1 plus charge. Now, as we've said before, they have opposite charges, so we could maybe kind of zoom out a little bit. We'll take a look at what these atoms are going to look like. Here we've got a chloride with a negative charge. We've got sodium with a positive charge, and they're going to stick together.
Why do they stick together? Because positive and negative attract. Yes. What kind of bond is that called? What are the two things sticking together? They are ions, therefore what type of bond is it? Ionic bond. Remember, ionic bonds form between metals and nonmetals.
Just like we've shown here. And that is because opposite charges attract.
So you can fill in that box at the bottom of the page. Opposite charges attract. Okie dokie. And that is an ionic bond. And we're going to leave it there for today and move on to page 31. There we go. Okay, so we're going to take a look today at names and formulas of simple ionic compounds. In Unit 4, we're going to get a lot more complicated, but Unit 3, we're just going to introduce you to the idea. Uh-oh, where did my page go? Oh dear. That's not what I want. I want this one. No, I want this one. No, I want this one. There we are. Okay. Good Lord. There. Okay. Whew. When we write the name and when we write the formula, who comes first? And when I say who comes first, what I'm talking about is, does the nonmetal come first or does the metal come first? Metal always goes first. Okay, so the metal always comes first. And the nonmetal always comes second. It's just like reading left to right across the periodic table. The metals appear on the left, the nonmetals appear on the right. So we do it in the same order as on the periodic table. And in order to name it, it's really simple. You just name the metal. Name the metal. Nope. And then, after that, you name the nonmetal, but because these are ions, and it's an anion, the metal is the cation, positive. The nonmetal is the anion, negative. What do we do to the ending of anions? The ending changes to "ide." How many syllables should be in that ion name? 2 syllables. So not nitrogide, but just nitride. Not oxygide, but just oxide. All right, so if we have a compound and it forms between the metal, magnesium, and the nonmetal, oxygen, what would we name it? Magnesium. Metal goes first. And then the nonmetal comes second. What's the name of oxygen when it becomes an ion? Oxide. And that's it. Super straightforward, yes? A compound forms between, this one's tricky, you'll have to think a little bit. A compound forms between nitrogen and aluminum. What is its name? See if you can write it down and then check with your partner and see if they get the same thing as you. What made this one trickier than the last one? What did I do? I flipped them around. I wrote the non-metal first, and I wrote the metal second. Does that mean that you switch the names around so that the non-metal comes first? No, you should still write the metal first, and then the non-metal should go second. Beautiful. Okay, so that's going to be, anyone want to give me the name? Someone who hasn't talked to me yet today? Yes, Ryan. Aluminum nitride, very nice. Okay, so it doesn't matter what order I write them in the question, it always goes metal first, non-metal second. Now, formulas, the word formula it refers to the chemical symbols. So the formula of an ionic compound just uses the element symbols from the periodic table. Okay? And the other thing we use are subscripts. Now, if you are a submarine, where do you go? Under the water or below the water. So sub means below. Script. Well, if you have a play and you have the script, that script is something that is written, yes? So script is writing. So subscripts are little numbers that go below the writing. Okay, little numbers that go below the writing. And what do they tell us? They tell us how many of that atom or ion there are. Okay, so they tell us how many of the atom or ion. Now, if there is only one of an element or ion, we do not write a subscript. And we can use something that we're really familiar with. Even if you've never really worked with formulas before, you probably know the formula of water. What is the formula for water? H2O. See, you guys knew that, even though you've never really necessarily studied chemical formulas. And you know it's not H2O1. Nobody wanders around and saying, water, H2O1. And that's because when we have only one, we use no subscript. Okay? If we have two atoms, we use a 2. And you can see in the molecule itself, there are 2 hydrogens and there is 1 oxygen. So the formula tells you how many of each atom. Let us try this question here. How many atoms of each element are in this molecule? How many sodiums, how many carbons? Try it, and then check with your neighbor. Yeah. Do you want to try it? Okay. We're now on page 31. 32, page 32. Sorry. You know what I'm going to do? I'm going to get out my cards, and I'm going to draw 4 cards, and those 4 people are going to tell me. So if you don't know, check with your neighbor, okay? Okay. How many sodium atoms are there max? There's 1 because it has no subscript. How many carbon atoms, Sophia? Shh. 2. Excellent. How many hydrogen atoms, Zoe Watt? 3. How many oxygen atoms? Valerie? There are 2. Beautiful. Okay. Ooh, a new word. This new word is, oh, sorry. The new word is formula unit. And it is a single unit of an ionic compound. It's like a molecule, but for ionic compounds. A formula unit is like a molecule, for an ionic compound. So what we're going to draw here is we are going to draw a formula unit that is made of 1 calcium ion, 1 Ca2+, and 2 chloride ions. So what that means is when we draw it, we're going to draw a circle to represent the calcium, and we're going to put Ca2+ inside that circle. And now we have 1 calcium ion. How many chloride ions do we need? Two. So you can put them anywhere you want. I usually tend to put them on either side just because it makes it symmetrical, and compounds tend to be symmetrical. Okay, so I'm going to take my circle here, chloride, and a circle here, chloride. And you see, I'm not very good at drawing circles. So you also do not have to be very good at drawing circles. If yours look more like triangles or squares, that's okay. Just do the best that you can. Try to write the formula for this compound. Once you've written it, check with your partner, see if you got the same thing. If you feel like neither you nor your partner know what you're doing, go check with someone else, because I'm going to draw a card for this one. Okay, formula. That goes to Matthew. What do you think? What? Sorry? Oh, okay. Just watch out for this. This is not an I. That is an L. Okay, so not CI. Does that make sense? Yeah. Cl minus, 2 at the bottom, Ca2 plus. That is an excellent guess. Okay? You're like halfway there. Who has to come first? The metal has to come first. So instead, we're going to put the calcium first. And just in case you're wondering, if you're like, oh my gosh, I don't want to be called because I don't want to get it wrong and all that, you learn the absolute most and it sticks with you the most if you get something wrong. Yes? It's just the absolute best. Yes?
Do you need to write the charges?
That's a very good question. Do you need to write the charges? And I haven't told you that yet. And the answer is no, we do not write the charges in ionic compounds. So it is just CaCl2. We do not write the charges. In the formulas of compounds. Take a look at that drawing of the formula unit that we've made and see if you can figure out why we don't write the charges. See if you can figure out why don't we write the charges. Have a chit chat about that with your neighbors. There's actually at least 2 or 3 good reasons. Okay, so anyone want to try one out? Anyone got any guesses? Thank you so much. Beautiful. Wonderful. And then if you wanted to go through those, yes, but they're all open to the page that needs erasing. Okay? Shh. Anyone got any guesses as to why we don't write the charges? Yeah, Hanan. Yep. There's 2 negatives and a positive, and what do those do to one another? They all cancel each other out. The charges all cancel out. The other reason is that if you've been doing chemistry for a couple of years, which if you decide to take chemistry 11, you'll have been doing it for 3 years, right? Grade 8, grade 9, grade 10. You will know that the charge of calcium is 2+ and the charge of chloride is negative, and you don't need anybody to write that for you in the formula. Okay? So once you've had experience with it, you don't need people to write that in the formula for you anymore. Okay? So it just means that when you get to that point where you know the charges, you've become fluent. Yes? But we're not there yet, but we still don't write the charges because that's just not how it's done. Could you name this compound here? See if you can name that compound. Write it down, check with your partner. All right. So let us name this compound. Oh, not here. Spencer. Sodium phosphide. Yes. Sodium phosphide. Remember, we have the metal first. And then the phosphide is 2 syllables. Ending in "ide." What would be the formula of this compound? Oh, I've heard from you today. Sue, what would be the formula of this compound? Na3P, yes. We have 3 of the sodiums and 1 of the phosphides. The metal goes first, the nonmetal second. What is the total positive charge in this compound? Everybody, what's the total positive charge in this compound? Positive. Oh, just if we're just looking at the positives.
Oh, just the positive?
Just the positive, it is positive 3, because there's 1, 2, 3. What is the total negative charge? Negative 3. What is the overall net charge? Nothing. No, just no charge. Shh. Nature loves for charge to be balanced. Nature loves zeros. It loves the positive and negative to be balanced. Nature loves zeros. Therefore, the net charge of every compound must be 0. Remember that every element starts with a capital letter. Okay, guys, we're almost done. Just hold on for I don't know how long. Not very long. Not very long. First letter is always a capital, and the second letter is always lowercase. Every time you see a new capital letter, that means you have a new element. So how many elements in KF? 2 elements. 1, 2. How many elements in MGBR2? 1, 2 elements. How many elements in NH4Cl? 1, 2, 3. And remember, L is L. I is going to be capital I. Yes? How about NaNO3? How many elements? 1, 2, 3. But in this unit, Unit 3, we're going to consider compounds made from only 2 elements for the most part, unless I'm just asking you how many atoms of each are in there. Okay? I'm not going to have you name anything with 3 elements in it. Okay? Just things with 2 elements. I will always use a font where the letter L and the letter I are significantly different. You'll notice that when I write an L, I usually write it like a cursive L, because then it doesn't look like an I. Yes? And when I write an I, I'm always going to put that top crossbar and the bottom crossbar on it so it looks like an I, not like an L. And often when I write the number 1, I'll write it like that, so it again looks different from an L. Okay, so here we have Cl. That's a C. Whoops. That's a C and that's an L. Okay, it's not a Ci. In fact, if you ever see Ci, it's probably wrong. Not 100% of the time, but most of the time. Ci would be wrong. They can bond it. The only time you might see it is you might see Ci4. Okay, but other than that, no. Is Cl2 an element or a compound? Element. What kind of an element is it? It is a diatomic element because it has how many atoms? 2 atoms. See if you can remind your partner who the other diatomic elements are. Matthew. Pardon me? Dioxide? Yeah, oxygen is one of them. Anyone got another one for me? Miriam?
Nitrogen.
Nitrogen. Anyone got another one? Well, chlorine, obviously, because it's there. Zoe? Hydrogen. And remember, if you don't remember, you can ask Dr. What was the name? Dr. Brinkelhoff. Okay, you can ask Dr. Brinkelhoff. So, what is one of the other ones? Br2, bromine. Who else are we missing on our list right now? Fluorine, F2, and iodine, I2. What if you don't like Dr. Brinkelhoff? What if you're like, I do not like the Dr. Brinkelhoff? How many of these are there? There are 7. Go to element number 7. Number 7. Draw a 7. See those yellow ones? Draw a 7. NOFCLBRI. That gives us 6. That's the hockey stick. What are we missing? We need the puck, which is hydrogen. Uh-oh. There we go. Okay? Hydrogen is the puck. There it is, over there. All right, where did you go? Bonding. Hockey stick and puck. There's also 2 rhymes. What's one of the rhymes? You can do a cheer. Yes, there's a cheer. H-O-N. Hey, low, Jen. H-O-N, Halo Jen. Ooh. So if you know who the halogens are, group 17, you're good to go. And then, if you don't like either of those, you should have no fear. What should you have no fear of? Have no fear of ice cold beer. Totally inappropriate for grade 9. That's why I'm not going to write that one down. But if you like it, you can remember it that way. If beer is nasty. Cody laughed at my joke? Okay. All right. Ki is an ionic compound. It is made from one potassium ion and one iodide ion. How do we know that it is a compound? Okay, you know what? We're done. We're going to go to page 25. And you're going to do page 25. And we'll pick up that other stuff next day, because you guys have been very, very good. You've listened lots. And can you take your test home? Yes, bring it back. Okay? Thank you. You can just put it anywhere. Perfect, thank you. Did you get your haircut? Looks good.